All right, let's go look at some other new stuff here. So we did some error handling. That was fun. Let me just go back to the menu here. Delegates. Oh, we'll come back to delegates and events. Let's do Lambda. We'll come back to those. So we've looked at some of these short syntaxes here, right? These expression-backed methods. We've done those before. So instead of having to count the number of times something shows up here, right, we can give it an expression-backed method. So count then will be numbers given n mod 2 equals 0. So it sort of is taking an if statement and throwing it in line. Gets a little funny looking. Where's our, right, we can figure out if we're even or not. Here's our arithmetic. And we don't even need to add separate functions here. So this is the beauty of it. It saves us a lot of time because I don't need to write different functions to do things. I can do it all in line if it's quick logic here. So in this case, count takes some stuff. So the count function can take another function here, take some integers, returns a Boolean. It's going to go through and tell me what the count is for whatever that count function happens to be. If it's true, right, if I get that Boolean back, I'll get back a true, and I'm going to count it. So being able to count, right, says, sure, here's your expression. It's sort of an anonymous function. So it defines it in place here, which is really fun. So you can have parameters. If you want parameters, they just go in parentheses. If you want no parameters, you get nothing, right? So you can infer types sometimes, right? So integers, right? We know it's an n because we're going to divide by n. We can do strings. Now, adding two strings together is a little silly, but we can concatenate strings. You can also like say, hey, you're going to give me some parameters, but I'm going to ignore them. So it's a common syntax to use the underscore to ignore things. So none of this was super fun, but let's go back to our project. I closed it. Let's go back to the poker project. Close this one, go back to poker. So if I wanted to say like, hey, let's count the number of times something shows up here. So I go to my poker hand class, and one of the things I might want to do is figure out how many aces I have or how many cards I have, right? So maybe one of the things we do when we compare, right, while we're tie breaking, right, remember in Yahtzee we set up the like number of occurrences of dice, and I said how many times did each die number show up? We get something like that, so we could have a list of int for, this is, I don't know, face counts, a new list of ints, and then I'm going to have 13 of them, right? Equals new, so 0, 0, 0, 0, 0, goodness gracious. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. New, there's a list of int. Okay. So I'm going to have this face count here, and I want to go through and count the number of times each face shows up. Right. So we probably would have done it the old way with a loop, right? I could say for card in cards. For each card in cards. I can get the face value out of the card. Right, so my face counts at the index of the card dot face. Remember that's an enum here. And I want that as a integer value. So was it 2, something like as an int. Maybe we can cast it as an int. Say, hey, I want that as an integer. I want to add 1 to it. So get the face enum, turn it back into an integer for me, and add 1 to that face count. Right? So it goes through my list here, and I add them in. But I've got a little loop here that does it. Right? A different way I can count it, right? Using some of these enums here, I can take my cards, and I can use this count cards. Where's my count? So cards.count here. I can give it some sort of function here that takes a card and gives me back a Boolean. This will return the number of times, how many elements in the sequence satisfied this condition, this predicate condition here. So we can give it another something to evaluate here. Right, this is that function of card and bool. So if we wanted, we could write our own function that does it. We could write a whole function that fits this card count, right, and give it something that fits here. Something that's a function, or we can use the anonymous Lambda stuff. So to do that, I give it an anonymous method. So Lambda is just a shorthand way to write a method without writing out the whole method. So all this one does is say, okay, my variable is going to be n. So I'm going to give you back a Boolean if you give me an integer n. So in our case, I'll give you back a Boolean if you give me a card. Right? So we're going to count this one here. So I'm going to say, this is, sorry, I got to match the right syntax here. So we got cards, cards, goodness gracious, card, yeah, function. So I don't know, card, I want lowercase, card.face, I can say equals, I don't know, this would be like card.face.ace. We can count how many aces we have. We can check the card face if it equals an ace. Shoot. What am I doing wrong here? The syntax always bothers me, sorry. Counting the cards. Count. I'm messing it up here. No, none of those are helpful. Cards? I'm losing it. I'm sorry. I'm a little tired.
Does it use a parenthesis instead of a caret?
No, we gotta have the piece here.
Before card.
Oh, before card? Count. Given our. Yes, thank you. That's right. It's not. It already knows it's a type card. Goodness, I don't need to tell it to type again. So card, lowercase card dot face. Goodness gracious. We'll get the right syntax here. So I can count how many times the card face shows up with an ace. Now this is not super useful for us. I don't really care specifically how many aces, right? I might just loop through and get my face counts this way. But instead of having to do a loop through every card and see, hey, does it match an ace? It essentially is doing this piece here inside. So it's going to count it if this part is true. So I have to give it something that returns a Boolean for a given card. And we can do any sort of crazy logic in there that we want. Like some of these, hey, is it between 100 and 1,000? Anything you want to throw in here, we could put like that. I keep doing the wrong one. Sorry, I want to click that logo instead of the other one. So we just get an anonymous method here. You could give it an actual function. You could define the function like in code like we normally do and hand it the function. We could do that too. The Lambda just lets us do it in line. So the idea is we start chaining all these things together, so we get these crazy looking, really long syntax things here. So I think that first example we had, where we're doing our flush tie breaks here, I said, okay, let us group by, right? Did it do, where was it in here? This one. So it's okay, order by descending. The order by descending function here, this method says, okay, tell me what it is. So we said, okay, what we're going to order by is the card.value. So for every card, get the value out, and that's what we're using to order by. So we can use that syntax here. So instead of having to write a function, hey, sort descending given a card, we can hand that to the Lambda notation here. Just lets us write, it's an anonymous function, an anonymous method. We get to do it in line. So it saves a little time here. So using all of these is kind of fun. You can do all sorts of fun things. There's like a group by. What do we want to group by? So I can group by how do I know what card I want to pick out here? Well, I want to group these. Maybe I want to group by card.face. So I can group them by my card face. Right? And it puts them all together now, and now I have an enumerable of a grouping. And they're grouped by the face here. So you can get this really long chain of, hey, let me group them by the face, and if you get the list back out here, you can do all this essentially in one line if you try hard enough. At some point it gets kind of hard to read. Right? Well, let's see if it'll give us something here. So how do we count how many times each face value shows up in our list of cards? I think it'll probably give us a long expression here. That's the hope. And if we can read it, we can go ahead and use it, because we know sort of what it's doing at this point, right? But if we look at what it gives us and we have no clue what's happening, that's no good. No, okay, it just does it. It does it the hard way. So it makes a dictionary count here. Well, that's fun. Adds all the cards, adds more cards as needed, loops through each key value pair. Count face values of the cards. Nope, that one just gives us a list of cards. That one's not very exciting here. Group by expression. See if we can make it do it. Hey! This is fun. It's a little messy looking, so can I put it in Visual Studio maybe? Let's do that. Let's throw that back over here. From chatbot, GPT. So takes our cards, right? That's going to be cards, our capital C cards. Cards dot, that's going to be face, right? For our purposes. So it's going to group the cards by their face value. Then it's going to go select for a given group. It's going to make a new something here, given a face value is the group key, and the count is the group count. Because what we get when we get a group by is we get a grouping. Well, I grouping then must have these values for key, right? So group is a grouping, so we can count on the grouping. So all sorts of, it's just an interface. Okay, that I grouping, so we can look at that interface if we care what it is. So we get the key out, and then it's going to order them by the face value. It's optional, but you see you just chain these things all together here. So we've got a lambda expression with another lambda expression with another lambda expression, and you just stick all of these things one after another, and you're like, hey, I wrote one line of code instead of a loop, and then another loop, and then another loop. Right? You can do it the same way without it, but people really love using LINQ. Eventually, it kind of feels fun that you can do all these things in one line here. Sometimes it's not very fun when you have to look through and see what's all happening here. I had one guy I worked with who had a 13-line long LINQ statement here. I was just so sad. Like, he was really impressed. Like, hey, look how cool this was. And like, grouping things together. Like, it was just gross at that point. But it gives us the shortcuts, right? So instead of doing it this way, right? So this will be an I ordered enumerable of A, where that's a new type here. Sure. So we're going to get the face value and then the count of that face value. So we don't have zeros if they're not existent. We just have what values do exist here, right? And then we can loop through and we can get the face value and we get the count of those face values. And console write line is not super handy here. Maybe we want to take our label, right? That's in the compare to. That's probably not where we want it here. Let's put this in. Where is our? I don't even want to do toString, do we? Excuse me. Can we put it in our form? Maybe can we do that in our code somewhere here. So we did the label here. Can we do another one? it'll be hand.cards. There we go. So let me add one more label here to our form. Make a label for, this is our, what do you call this? Face counts label. Okay. And then when this code runs, we'll take our face count label, face count label, text plus equals that. Maybe we want it equals to start. All right, we'll set it to blank to start here. So we'll set, otherwise we would just append this thing forever, right? If we ever just only keep adding to it, and then we want some new lines in here too, right? So plus a environment.newLine. Okay, let's give that a run. So we get back out. So there's 1, 2, 1, 5, 1, 6, 1, 9, 1, 10. Seems like it matches. 2, 5, 6, 9, 10. Hey, now we have two 4s, 4 and 4. Right? Hey, 2 10s, we have a 2 pair. Right? So using this sort of, now I've got this really funky looking expression here, I can do something with it. So if I have this face counts, right, then I can do other silly things in poker hand, right, as I'm comparing rank in here. I can say, this is now just cards, right? If my face value counts, nope, face value counts dot, is it, how do we loop through those? Hang on, what do we have in here? We have to go back and look. If the, every face value count, and I wanted the count of it here. So face value counts dot, we can count of that, right? So count, I don't know, this is a count. Count dot, and I've got two things. I have the count, count. Maybe we should call that like the group. Face count, how about that? So for a given face count here, if the count of the face count is equal to a 2, right? Somewhere in here, then I have a pair. Why is it, am I not enough parentheses? Count, face count equals 2. Oh, if the, not the count, sorry, if contains, there we go. No? Shoot. All right, so this count would give me how many pairs I do have. If that one equals 2, I can return, this is going to be 2 pair. Right? Is this my hand rank? No, that's in compare to. 2 pair. So we're saying, hey, count all of my counts here that have a count of 2. If I have 2 counts of 2, I have 2 pairs. So looks pretty ridiculous, right? But we could throw all these together in these long statements here for fun. And then once I have my pairs, then I can look at, hey, give me the first pair, see if that one's higher or not. Give me the second pair, see if that one's higher or not. And then give me the last card, right? So give me the face count where I only had 1. So let's go through all this. So, right, if I've got a 2 pair here, right, I have 2 pairs. Let's compare the first 2 pair to the other 2 pair. So I know our hand ranks must be the same because we're not separate. We haven't even figured this out yet, right? But we'll get to that eventually. So when we're tie breaking, right, get mine and get theirs. So I've sorted by face value, right? So in that list here then, right, when we looked at our form, we had the smallest pair first and then the largest pair next, right, in our group here. So maybe we want to loop through. We can say for var face count, sure, in face value counts for each. Oh my goodness. So as I'm looping through these ones here then, right, through each face count, I need to find my face count and the other's face count. So I probably need the other's face count as well here. This will be other.cards. This is the other face value counts. So take the others cards, do this exact same thing, right? Group them all together here. So we're going to compare my face count to their face count. And let's do these, can we do descending? I don't know if that probably doesn't matter. So we need to find the higher pair here. Well, we only really have 2 that should be a pair at this point, right? So if I want to not have to deal with the third card, we can do more of this link nonsense here, right? I'm going to say, hey, let's do that first. So let's grab the pairs first. So I want to say, here's a var for pairs, will be my face value counts. And I can select and say, hey, I want to grab the, I don't know, face counts, where what is going to be true. What will tell me which ones I want here? So I want to grab just the ones where something matches, where my face count is to. Right? And then I want to order by, and I can order this by, oh, goodness gracious. Hit the wrong key. Too many keys here. That one. Face value? No, order by, so this is my face value count, face count dot. I lost my select. I'm not getting it back. Select. Oh, no, sorry. We got to select this way. We don't want the select, sorry. This will give you a new something out here. We want where face count is 2. Dot order by face value. And we want to order by descending. Order by descending. The suggestions here are not working for me well. So I'm going to order mine where the face count is 2. So that will limit the ones that I have to where I have the count being 2. And then it's going to order them descending. So whatever's left after that, I'm going to sort in reverse order because I want the first one first and the next one next. Or we can just order by. We're just having some fun with this. So this will be my pairs. And we'll repeat it for the other pairs. We'll have other pairs. So this will be the other face value counts, right? Now I can compare. If my pairs, now I've got the first one, right? Dot, right, pairs, oh, it's enumerable, goodness. All right, I need the first one, pairs dot first. Dot face value is equal to the other's first face value. So grab the first thing that's in here. So IEnumerable is a little weird. It's not actually a list, this I ordered enumerable. You only get so many things out of here. So like pairs dot, I only get a couple options here. There is no like, hey, I want to get something at a given index. Because it's only enumerable, so you can only loop over it individually in a for loop. Or, hey, I want to grab the first one out, I want to grab the next one out. Got some options. So grab the first one. If it matches, then I need to compare the next one. All right, do that. So if they match, this is getting really ugly looking, right? It's all right, we're just having fun. You're having fun, right? It's fun. Who knew you could get code that looks so pretty like this? So if the firsts match, well, then I want to look at the next one here. So I can't really loop through the, I could do 2 different loops. It gets a little weird as I'm going through. But let's check, hey, if my pairs dot, now there is no second, but you can say I want to take so many here. I could take the values out. So this might be easier instead of getting first here. Let's do that. So let's do, so if I don't want it to be an I ordered enumerable, if I want it to be something that's workable, there's a to list option. So I'm going to take all these to a list. This will make life a little easier for us. Now if I have to list here, I can say pairs at 0, face value. I like this better. 0 is a face value. So if they match, right, and the next ones match, or any way we want to compare these, or we can loop through, we can do a little for loop, right? Maybe the for loop. So for index is 0, index is less than pairs.count index plus plus. And then if my pairs at the index is less than the other pairs at the index, return -1. I must be less than, oh, sorry, pairs at index dot face value compared to their face value. So compare the two face values. If I'm less than, return to -1. If I'm not less than, right, else if I'm greater than, return a +1. If I've gone through my first pair and my second pair and they match, and I haven't returned something yet, I can return 0. We're both two pairs. Oh, we can't even return 0 yet. We need to now compare the last card. Right, we have a last card. All right, well, let's go back to our face counts. This will be really ugly, but no, we can say return. We'll do it on one line because everyone loves doing stuff on one line. So we'll take our face counts, where my face count dot count, face count, right? Face counts? No, face value counts. Sorry, face value counts. Face value counts. Face count dot count is equal to 1. I want that one, right? I'm going to grab just the one where it's equal to 1 because I know there should only be one left. So I'm going to take that one and I'm going to take its first, maybe? The first one that we get here. Its face value minus the other one. Because it could be equal. Might be separate. Other face value count. All right, we need to put a bunch of notes in here, right? Because this doesn't make any sense yet. Do you sort of see where this is going, right? So in your face value counts, grab the one that there's a single of. Because I know I had two pairs. So there was 2, 2, and 1. Had to be. That's the only option there is. So grab the first one that matches. Because remember, this is this IEnumerable thing. If I wanted that like to list, I could grab index 0. Should we do that, to list, and take index 0 out? Its face value. Does that look better than first? Right? Turn it into a list. Grab the first item out of the list. So we're going to limit, get just face value counts where count is 1, and compare that face value to the other face value. Right? This one limits, find just the face value counts that have count of 2. Right? Those are the pairs. You can do all sorts of fun stuff here. Now, do you think this is easier than doing loops? Nah. Maybe? I mean, like, having to count all the face values here would not have been too bad, right? When we had here, I would just loop through this and find the 2's, right? And I could go backwards through them and find a 2, maybe? Right? I don't know if we've done anything better here with link, but it looks fun. It looks fancier, right? So with this face count list, because we're in order of our faces, right? Because we took the enums here, we would just go backwards and find the first 2 and say, hey, if we found a 2 here and that one's not a 2, I must be bigger, right? That sort of thing. So we'd have to do some other kind of logic to repeat that with this face count versus getting all these face counts out this way. All the link stuff is lots of fun, but it's just anonymous methods. It's just creating a method that gives you back a true or false, essentially. And you can throw them in all sorts of things. You can count, you can order, you can where. Any of these things here, these are all just extension methods that give you something. The select is a little weird because this creates like this, where it says A is an anonymous class, essentially here. So we made this new keyword, says, hey, make a new class. where you have a face and a count. So I don't need to write code that will help me track a face value and a count as its own separate object. We're just now doing this sort of by name. So because I called it face value and because I called it count, I can get face value and count everywhere else here. They only exist because of this new keyword. So the new keyword creates an anonymous class, the attributes as named. Then you can have as many attributes as you want in here, right? You can say apple and give it a value here. Right, so if I just comma separate, say like apple equals apple. Now all of my face counts now have an apple. I don't know why, but we could. So anywhere I have face counts, right? I can say face count dot apple. It exists because I defined it here in my new function. It's really powerful. So it just saves us the typing of, let me define a class and create instances of that class. It's just shortcuts. We could do it that way. We could make our own, hey, here's a face count class that has attributes for the face key and the count. That's the hard way. So it just gives us lots of shortcuts. So a lot of times we'll see this weird stuff come out of the chatbot. This is why it's super helpful to understand what it's doing. Now, we got lucky the first time it didn't, right? Until we asked for it, right? It didn't do that. But when we asked for it, it gave us this fun nonsense that groups and selects and orders and does all those things for us. So we just kind of work through that chain of, okay, this thing happens first, and then this thing happens here, and then this thing happens here. We throw them all together. So the where clause here is super handy for filtering lists. Anything that we have as IEnumerable, you can do a where on. And say, okay, here's a big list. I want where something is true. And we can give it some sort of expression here, this lambda, this anonymous expression, here, this anonymous function, that will go and tell me yes, true, or false. And I can now limit my counts here pretty quick. So like, if we had this face value counts as something here, right? We can have a public Boolean, I don't know, is 4 of a kind, right? And pretty quick in here, we can get our face value counts, right? Essentially this, I don't even need to order by descending, right? I just want this, oh, I don't actually want apple in here, sorry. Let me take that back out. I just want this piece here. So my 4 of a kind then can return cards grouped by card face, select key in the count, grouped by count, dot, to list maybe? Or so let's do the select and then dot where. Let me bump this down to the next line. Oh, it's fun, you can click those. It's really annoying. Where my, what is that, face count group dot count equals 4 dot, I don't know what, to list dot count is 1. So group them together, right? Group by the card face, get the groupings out here, where the group is 4. Don't even really need to turn that into its own selector. I think we can just say where here. So group by the card. What was group by? Group by give me the grouping. So I think I just need the group.count. Let's skip this line. So I think we can say where group.count. Group.count is 4. Did it count? Oh, shoot. I broke it. No. I guess we got to group it together. I thought we could just use group. Oh, the count function. Okay, count function. There we go. Group.count equals 4. So group them together. If the group count is 4, and we turn that into a list, we count that size of the list. If that equals 1, otherwise it's 0, right? If I don't have a 4 of a kind, and this is just true or false. This is kind of nice to have as a one-liner, right? But you could also, like, if you had this card face counts as a value somewhere, we could see if this one contains the value 4. Right? You don't have to do all of that each individual time here. So maybe every time we added a card, we could change this here, right? As cards change, maybe we want to go and compute that sometimes, or figure out the card ranks, right? So the other option we had, right, there was our face counts. We could return face counts dot contains 4. Is that easier than this one? Right? Both ways work. All right, we had enough fun? All right, so next week then, we got a couple things still. We're going to talk about delegates and events. So these are delegates. We'll get more into what that actually means. It might make a little more sense if we talk about delegates. Events are super fun. How graphical user interface applications are event-based. As things get clicked on, things happen. We can use our own events to make stuff happen when things change, which is really fun. And then we'll talk about threading and a little bit of async programming next week. Yeah.
So do you want us to use your builder code specifically, or
No.
use it as heavy inspiration for?
If you want it, go for it. If you don't like it, don't like it. That's fine. Yep. Yeah, we can do a lot of this stuff with it.
Yeah.
That's all. But you don't have to. And it gets pretty messy looking, right? And that's okay, right? There's lots of different ways to go about it here. We're just trying to play with some of these things here. So using this link syntax is going to take a while because it's super weird looking to start,
Yeah.
right? But here's the item, here's what I want out of it here with this little lambda. So we've done the expression-backed properties. It's essentially an expression-backed method. So say, here's the thing, here's my method, but it is just in one, in a little bit of code here. So just like we could take a property and make it be an expression, like the rectangle area was just length times width. It just looked like it was a property. Same idea here. We're just giving it the expression. Here's the code that runs instead of a function. And we just save some curly braces. So lots of fun stuff. People love link code in C#. We'll see it all the time. Anytime we're dealing with collections of things, which a lot of times we are, because we're working with bunches of values at a time here, especially when we start working with databases. So after we come back from break and we work with databases, all this link stuff will be super handy. And we'll use all this link stuff when we work with databases. It just makes life really easy for us. We don't have to know anything about databases or SQL to work with databases. It's really fun. So we'll get there. All right, it's been a long night. Thanks. If you got questions, let me know. We've got some time, so don't sweat it. But do get started at some point rather than later for that project, right? We got until the 14th when we come back. All right. See you folks next week.